are still on chapter 2. Now we're gonna do the third part, which is our first function, a straight line function. So a straight line function is a linear function, or we can call it a straight line or a linear function. So it's like a function that is represented in a straight line. So here we have an example of a straight line. So mainly a straight line is represented by the formula y equals to mx plus c. Y equals to mx plus c. So m is the gradient, which is the slope. So the slope determines how whether the straight line is steep or the straight line is flat. So the higher the gradient, then the function is steep, but the lower the gradient, then our straight line will be more vertical. So that's what the gradient is for. Then we have x. Our x is our x-axis. So this is our input, so the number that you have to input. Then our output will be the y-axis. So our output is the y-axis that we got from using the x-axis. Then c is the y-intercept, because like if x becomes 0, then we know that y must be equal to c. So that's why we say c is our y-intercept, because like for here, as you can see, x is 0, then it's 1. Then as you can see from the formula, y equals to m, which is 1, x is our input, plus 1, which is our y-intercept. So yeah, here let's try and maybe show you what the how you work with the straight line. So for here, let's find let's try and calculate the intercepts using the formula. So as I said for the y-intercept, x has to be 0. So y equals to m, then we multiply by 0, then we add our value. So from this you can see that our y equals to 1. So now you can say that our our y-intercept is given by the value of 0 for x and 1 for y. So the same applies for the x-intercept. Just make the y value must be 0, then our x can be 1. Our x is x, so yeah, our x is x. Then here we have 1, yeah. So then we know that our x-intercept was to 0, yeah. So now we know, because like we know, like we don't need our gradient for this one. So yeah, this is how you calculate the intercept. So yeah, let me prove that our gradient is 1. So for gradient we have a formula. There's like this formula whereby you can calculate the average between 2 points. So yeah, let's use that formula. I'm gonna show you guys. So yeah, it will be the last part for linear, so be patient. So yeah, let's calculate the last part about so our gradient, which is m, it will be let me use this one and copy. Then let's say y2 minus y1. I think you guys know the formula. So slow, so slow. So yeah, we can take let's take this point. So it will be minus 2 for x and minus 1 for the y. So it will be our first point. So here, so it will be negative 1 for the y. Then here we're gonna take let's take 3 and 2. So here it will be 3. So for the first one, we said it's 1 minus 1, and let me see, minus 1, and yeah. So here is gonna be minus 2, and 3 goes with 2. So yeah, as you can see, it's gonna be minus 4 over minus 4. So we know it's 1. So I was just proving this one for you guys so that you can know. So this is how we deal with a linear function, a straight line function. So thank you guys. Subscribe to our channel.